All right, so here's the primary MMC. So that's going to be about, I kind of rearranged that. So that's about 13 nanofarad, about 10 turns, something like that. All right, so for one, I can't really be comparing the voltages here, like the peak ramp voltage to how it was before, because there was a had a much lower impedance primary. So I'm not actually sure at what point those really should be reaching out. So again, that's 100. I kind of noticed the same thing on that first one when I switched to primary feedback. So let me see here. Huh. All right, so that's about 150. All right. And then turning it back down to about 100. Very, very slight increase back up to 150. So going up, from like 1 to 150 doesn't seem to make very much of a difference at all. Cut the on time up a little bit. So they're less branchy with this setup, because now instead of about 300 kilohertz, again, about that's about 420. Just tweak the tuning ever so slightly. I'm just put it back to 150 again, and then so that's the lowest on time. So the ramp is, I'll say it, for one, the ramp waveform itself looks more crisp, right? There's not doesn't really slope over. Even when I turn the on time all the way up, I mean, it just barely kind of starts to. Ooh. Oh, that was a. I cut it up a lot and it got a bad arc or a bad streak, and the OCD kicked in. So anyway, had to back it down just a hair. Cut the on time back up. Yeah, so for one, I think every now and then there's going to be interference with that OCD circuit. Yep, there it goes again. So that's one thing I've noticed. Every now and then when that OCD circuit kind of wigs out, then it encourages primary streaking like that. Normally I wouldn't really complain about something like that for 100 volts. But the arcs from secondary feedback were just a whole lot meaner. They weren't as straight. These are more like straight lines. So I feel like I would prefer this more once I get the voltage all the way up. But yeah, so far that's what I got. Just the first tuning. So luckily didn't really have to do much. All right, now I've changed out the top load. Basically what that is that's a old used up soldering iron tip. I've sort of tried to like sharpen a little bit. So that's what I had on the previous top load. So I didn't really like the way the arcs would kind of come out and split all the time from the thinner wire. So Just kind of throwing this on there. I'm gonna have the arcs kind of shoot out to the side. So again, back down to the lowest on time. It does make a difference, right? That top load, I mean the breakout point, it's a little bit thicker. I believe there's still some copper there. So as the actual arc jumps out at the base, it starts out a little bit thicker. Cut the on time up. Yeah, so something like that's cool. Let's see if I can cut the brightness up. I guess not. All right, anyway, what's that? So that's about, yeah, so that's about 100 right there. So I think, I don't know, I was something close to like 150 when it started to wig out before. So I'm not going to go all the way up to like 150. So again, that's about, 130, something like that. So again, that's still the original tuning that I had. I haven't changed anything. That's just, I've changed around that breakout point just so it's not going all over the place. So as you can see, it's pretty damn consistent. That's what I like about it. It's just it's the same sword that comes out damn near in the same exact path. Doesn't deviate a whole lot. The whole way through, it looks pretty smooth. Every now and then, of course, it's going to do it. But there's not a whole lot of like little artifacts that sort of occur here and there, right? Yeah, so that's pretty cool. Which is also reflected in the actual ramp waveform. So that's a huge difference compared to the secondary feedback. And again, I'm not knocking the secondary feedback. I really like that. It's very simple. Got really good, nice output. It was just a lot more branchy. Some of that had to do with the way that I had the PLL set, which is another thing I sort of need to tweak around on here. Tweaking the way that PLL is set can really change how those arcs propagate. But right now it just seemed, I just kind of left it where it was because it seemed pretty clean. It almost looks like what a setup would look like, let's just say if it was like, if it had a little bit too much delay in it, right? You had a little bit too much phase delay. So, you'd have to just bring the voltage up really, really high to get the output you probably should be getting at lower voltage. So I say that in here, that's sort of synonymous with, I probably need to tweak that tuning around a little bit more. It's kind of, honestly, doesn't seem like it's really too far off tune. I mean, it's hard to tell, but I bet if I adjusted maybe like a couple of those turns, because for some reason, again, like with this setup, normally tuning a DRSSTC, it seems like shifting around too many of those turns, you're really going to see a huge difference. Getting the peak tuning, let's just say the best tuning you could get, for me it seemed like we're talking about like a quarter turn difference, right? But in this case, I bet I could remove like a whole turn or two and not really notice a whole lot of difference, right? So that's kind of what I remember. It was a little bit difficult to get the tuning right, and it was a little counterintuitive. But I'll say at some point, can't remember exactly what happened. At some point, I just kind of landed on a tuning where I was like, oh, okay, this actually looks pretty good. And at that tuning with the other setup, which is pretty identical to this, I'd say about that 150, 170 volts, that's when those arcs were really jumping out. Those are nowhere close to what I was getting yet. I mean, they're not bad for a first tuning, right? But they're just not cutting it. So we'll have to see how that thing works out.